Welcome my colleagues and my dear students, and today I am speaking about a very important topic in biology, which is action potential or the nerve impulse. So what is the action potential or the nerve impulse? As I said in the previous lecture of the resting membrane potential, the action potential is related to the resting membrane potential. So we must have resting membrane potential in order to obtain action potential. Action potential are signals that are transmitted from one part to another part, by which we see, we hear, we move, we smell, taste, digestion, respiration. Every activity in our life is done through nerve impulses. So what is the base of nerve impulse? We have important principles. First, what is the polarized state? Polarized state means that the outside is positive regarding the inside, and this is the unstimulated or resting state. In the neurons, in the average, it is about minus 70 millivolts. If this potential difference is decreased, the process is called depolarization. So if the value of the resting potential is decreased than the resting value, this is called a process of depolarization. If the potential becomes a positive 35, so the poles are reversed. So we have a positive pole inside and the negative outside. This is the reverse of the polarized state. So we call it depolarization with reverse of polarity. So we have two conditions of depolarization. There may be depolarization without reverse of polarity, just only the potential difference decreased regarding the resting state. The second is depolarization with reverse of polarity. If the membrane potential returns again to the resting state, we call the process repolarization. It is return from depolarization to the normal polarized state. What about hyperpolarization? If the potential exceeds the normal resting level, so that minus 70 becomes minus 80, we call it hyperpolarization. It is a normal phenomenon that occurs during impulse transmission. However, it rapidly returns to the polarized state. So what is the definition of action potential? Action potential is sudden change that occur on top of resting membrane potential. We must have resting membrane potential in order to obtain action potential. These rapid changes are initiated by effective stimuli, and these changes propagate, spread along the nerve and reach the effector organ where they produce actions. So we call them action potentials because these potentials produce actions like senses, like motor activity, like biological activity, and so on. When you stimulate by effective stimulus, you will generate action potential, an electric message which travel along nerves and reach the effector organ where they produce actions. The nerve impulse is a wave of depolarization on a membrane that is in a resting polarized state, and this is followed suddenly by a wave of repolarization which return everything to its resting condition. The third event is redistribution or rearrangement of ion after the process of depolarization and repolarization. This is a nerve in the resting state. When you stimulate by effective stimulus, the depolarization wave spreads, and it can be repeated many times. It is just a message. It is just a wave of depolarization followed immediately by a wave of repolarization. Depolarization is loss of the normal polarized resting state. The membrane potential decreases from its resting value. In nerves and during generation of the nerve impulse, the membrane potential decreases to zero and it overshoots towards the positive side, towards positive 30 millivolts. So it is called a state of depolarization with reverse of polarity. The most suitable ion to produce a very rapid depolarization is sodium. Why? Because the concentration of sodium outside is about 10 times the concentration inside. Also, sodium is positive while the inside is negative. We know well that ions are controlled by concentration gradient and electrical gradient. In this condition, the concentration gradient force and the electrical gradient force are with sodium. So when its voltage gated channels open during the nerve impulse, it will get inside the cell so rapidly and produce depolarization. So the process of depolarization is produced by sodium influx. What about the process of repolarization? To repolarize the membrane rapidly, we have only potassium ion to achieve this. Because while the membrane is depolarized, the outside is negative. Potassium inside is positive. So the electrical potential is with movement of potassium outside. Also the concentration gradient. Potassium is inside 35 times the concentration outside. So when voltage-gated potassium channels open, potassium moves rapidly outside and achieves the process of repolarization. This is the voltage-gated channels which opens and closes by voltage. Both sodium and the potassium channels are programmed to open and close at certain voltage when the impulse is initiated. In depolarization, the membrane potential it changes from its resting unstimulated condition -70 millivolt towards positive 35 millivolt, which is a cold overshot. The process of depolarization occurs in two stages. First, a slow stage. Second, a rapid stage. In the slow state, we move from -70 to -55. However, from -55 to positive 35, the process of depolarization is so rapid because of opening of all sodium channels. So depolarization is a process by which the membrane potential changes from -70 to +35, and it is divided into two steps: slow depolarization and rapid depolarization. Slow depolarization from -70 to -55 and rapid from -55 to +35. So -55 is a critical point which is called firing level or threshold level because it is point at which the program of the impulse starts. Actually, the program starts at -55. At this point, the generation of the nerve impulse is irreversible. It can't be stopped. The channels work in sequence as the program of the nerve impulse. When we reach the top, which is +35, sodium channels close and voltage-gated potassium channels opens, and this causes the process of repolarization. The process of repolarization needs two important events to occur. First, stoppage of sodium influx. Second, beginning of potassium efflux. This is a simple figure for the action potential. We started to stimulate here. This is the start of the process of depolarization. As we see in the figure, this is the resting potential -70 millivolt, and this is the overshot, which is +35. The red color represents the process of depolarization, which is slow between -70 and -55 and rapidly after -55 and until reaching a +35. The green colored line represents the process of repolarization, which is rapid at first, then it becomes slow. This part of potential is called negative after potential because the membrane is still partially depolarized. However, after reaching the resting state, we find that the membrane exceeds the resting state. This condition or this part of the curve is called positive after potential because the process of repolarization is exceeded. So at this condition, the membrane is hyperpolarized. However, rapidly the membrane rearranges itself and finally gets the complete state of repolarization. This figure represents the process of recording of action potential, which is called monophasic action potential. Suppose this is the apparatus that measures and make a diagram of the action potential, which is called CRO, cathode ray oscilloscope. Suppose we stimulate by effective stimulus at this point. This is a nerve and this represents the recall. First, when the impulse is initiated, it travels. This initial part before start of the record is called latent period. Then the process of depolarization occurs, followed by the process of repolarization. There is a latent period, the lag of time between start of stimulation and start of record. Then there is slow depolarization, then there is rapid depolarization, then rapid repolarization, negative after potential and positive after potential. There is slow sodium influx from minus 70 to minus 55, then it becomes rapid from minus 55 to positive 35. Then the process of repolarization starts by exit of potassium to the outside. First, it moves rapidly, then it moves slowly to move negative after potential, and this is followed by positive after potential. Finally, there is a step of rearrangement of ions which are disturbed during the process of depolarization and the process of repolarization. See you again. Goodbye.